Hi Calculus, welcome to section 8.3. This week we're going to apply much of what you learned last week, or in the last lesson, of critical points to some story problems. We're going to be looking for maximum or minimum values depending upon what the story problem is focusing on. Some key steps. You're going to want to sketch. You're going to write an equation for the variable. These are going to use some basic formulas that you already know, things like area formulas, Pythagorean. You eventually want to get the equation in terms of one variable, and then you're going to check those critical points. So find where the derivative is 0 to find minimums or maximums, and you're going to check the endpoints too. The best way to do this is to look at some examples. Ellie has 600 feet of fencing to enclose 2 fields. One field will be a rectangle twice as long as it is wide and must contain at least 800 square feet. The other field will be a square and must contain at least 100 square feet. What fields give her the maximum area? Let's start with a sketch. Here are my 2 fields, a rectangle, where it is twice as long as it is wide, and a square. Now, if we want to find the area, let's write out our area formula. The area would equal 2x squared, the area of the first, plus y squared, the area of the square. The perimeter would be 6x plus 4y, and our perimeter is going to be 600. We can solve that for y so that we know y is equal to 150 minus 1.5x. The reason I solve this for y is, remember, we're going to need this in terms of one variable. I'm going to substitute 150 minus 1.5x back into my area equation for y. So my area is going to be equal to 2x squared plus, instead of y squared, I'm going to have 150 minus 1.5x quantity squared. I'm going to simplify this down on a blank slide. Expanding and combining like terms tells us that our area is equal to 4.25x squared minus 450x plus 22,500. Remember, we're now looking for critical points, so we need to take the derivative. So a prime is going to equal 8.5x minus 450. Last week we learned that to find our critical points, we should set the derivative equal to 0. If 0 is equal to 8.5x minus 450, that implies that x is equal to 52.94. This is a critical point, but what happens there? Pulling up a graph of my area equation indicates that at 52.94, there's a minimum. Clearly, that's not going to give us the biggest area. That means we're going to have to check the endpoints. The key question is, what really are the endpoints in this problem? To find our endpoint, we really need to find the domain of this function. If you go back and reread what they gave us in the problem, we were told that the rectangle's area must be greater than or equal to 800. Well, the rectangle's area was 2x squared. So 2x squared greater than or equal to 800 means that x has to be greater than or equal to 20. The square's area must be greater than or equal to 100. If y squared is greater than or equal to 100, that implies that y is greater than or equal to 10. Previously, we solved for y in terms of x. Substituting that back in, 150 minus 1.5x is greater than or equal to 10. That means that x is less than or equal to 93.3. We're going to use our area formula and substitute in our 2 endpoints. If x is 20, we end up with an area of 15,200. When x is 93.3, we end up with an area of 17,522, clearly the larger area. Substituting back into our perimeter formula gives us the following dimensions.